So, practice test day 2. Yesterday we went through 1 through 11. Today we're going to do the 12 through, I think it's 22 for the last one. So, use the given information to write an explicit geometric rule. So, I kind of stop right here and think to myself, explicit geometric rule. Let's see. The geometric ones don't have addition. They have multiplication. And if you multiply enough times, you're talking about powers. So then I look at my little formula sheet for the test, and I realize it's going to be that one. Now I need to remember that I have to put in the first term, and I have to figure out what R is. Those are the two things that I have to find. So far, all I see up there is the first term. So that means they must have given me something that's supposed to help me figure out what R is, because I can't write it if I don't have R. So if they did that, that means something up there is supposed to go in this spot, and it's going to give me whatever that is. So, what should I put in for n? 4. And yeah, you're right, it'll become 3, because 4 minus 1 is 3. And if you do that, what are you supposed to get? A 2/5. Yeah, if you put a 4 in, you're supposed to get a 2/5. That's what's supposed to happen. So now I look at that and I think, well, that won't be too bad. We can divide both sides by 400, and that's not going to look fantastic, but you can think of that as multiplying both sides by 1 over 400 if you want to keep it a nice fraction, or you can use your calculator and hit math fraction number 1. So this would be 1 over, and then this would reduce to 200 times 5, which is 1,000. And now this one, our calculator does do cubed roots. So instead of trying to get the bases to be the same and all that kind of stuff, we just take the cubed root. Although I'm guessing we might not need a calculator for this one, because what's the cubed root of 1, everybody? 1. And what do you multiply times itself 3 times to get 1,000? 10. But let's just say you didn't want to do any of that in your noggin. You wouldn't have to. We could take 2/5 and divide it by 400, and then take math number 4, the cubed root of that answer. Math number 1, voila, there it is. It's 1/10. So either way, we're going to get an R of 1/10. Now we're not done, but we're super close, because remember that was the only thing that we needed. So A sub n equals our 400 times our lovely 1/10 to the n minus 1. That's the explicit rule. So that can go right up here in this little blank. But there was a follow-up, and the follow-up is making us use it. It says we're supposed to find the 7th term. How do you do that? Yeah, put that little n up there as a 7, and you grab your calculator and you do some cranking. So 400, parentheses, 1/10 to the 6th. I wouldn't put 7 minus 1 in there. We know what 7 minus 1 is. And then math number 1, enter. Oh, that means we have to do that one on our own. 4 times 10 to the negative 4th. Uh-oh. What are negative scientific notations for? Yeah, itty-bitty little numbers. So we're going to need to move. This is a 4, and its decimal right now is right there. We're going to need to move it 1, 2, 3, 4 times. And what do we put in those positions? Zeros. So I don't know that I could fit that in there. Let me write it over here. And you could write it as 4/10,000ths if you wanted to and reduce it and make it a fraction, but I'll take it as a decimal. Not a problem. Alrighty. That's 12. This is 13. That's got to be lucky, right? What is the sum of the finite arithmetic series 17, 25, 33, 41, all the way up to 209, huh? Okay. Sum. That means I need one of those big S formulas. And this one is arithmetic, which means I better be looking for a D or a plus. There's the plus. Again, you're getting the formulas. They're just not going to be labeled for what they are. Alrighty, first things first. This formula says I need to know how many there are. Oops. I don't. Well, then you got to use the rule to find it. That's what always happens. The rule is always the backup. So a sub n equals a sub 1 plus n minus 1 times d. All right. To write that rule, we need the first term. Do we know that? That's 17. And we need to know what they're adding every time, because that's d. What's d? What are they adding every time? 8. So my rule says 17 plus 8n minus 8, which is 8n plus 9. Now what do we do that for again? Because we don't know how many terms there are. But I know the last one is 209. So where should I put the 209 to figure out what n is? Yeah, a sub n. Put the 209 right here. And then do a little math. So subtract 9. Divide. $2 divided into 8 equal pieces. How much is each piece? 25 cents. N is 25. Or you use a calculator, for goodness sake. I mean, you don't have to do any of this in your noggin if you don't want to. There it is. All right, so there's n. Cool. Now we have n. Let's see if we have everything else. Oops, I better scroll a little farther. Okay. Well, do we know what the first term is? What is it? Yeah, 17 is sitting right there. 17. Do we know what the last term is? Yeah, in fact, we just used it, didn't we? Well, now we have everything. So we just do some real basic math here. We'll be okay. So let's see. Oh, 25 halves isn't going to be anything nice, is it? So then maybe we do just punch it all in. But I would probably just add these in my noggin real quick and say, ooh, 9 plus 7 is 16. Carry the 1. That's going to be 226. And then punch it in. 25 halves times 226. 2,825. Beautiful answer for my little slot over here. Ta-da! So if anything's ever missing from one of your sum formulas, find it by using the rule. All right. 14. Find the sum of the finite series. We've got lots of formulas. Does this look like it's arithmetic? Does that look like y equals mx plus b? Uh-oh. Nope, it's got a cube there. Does it look like some number times some number to a power? Doesn't look like it's geometric either. Ideas. If we're not giving up, what could we do? We're back to the stare at it and hope it goes away method. It's not working. It's not working. Well, what's the first number we're supposed to put in there? A 1. Do we know what the second number is? A 2. And how far do we go? 7, because the 7's on the top. We're just going to have to crank them out and find it. So we're going to put those numbers in, and it's going to kick out the terms, and we'll add them together. Let's see. 1 cubed is 1. 1 plus 2 is 3. That's not so big and scary yet. 2 cubed is 8. 8 plus 2 is 10. 3 cubed, 27. 27 plus 2 is 29. 4 cubed, 64. 64 plus 2, 66. And you can do this on your calculator. 5 cubed, 125 plus 2, 127. 6 cubed, 216 plus 2. How about 7 cubed? Did anybody memorize 7 cubed? Yeah, there's too many people looking at me like, no, I didn't memorize that one, senior home. 343, add 2. I'm going to have to add them all up, because that's what sigma means. Sigma means find the sum. $798. Check my math. Those of you that punched it in, you get 798. Okay, so this one, it doesn't fit. It doesn't look like mx plus b. That's what arithmetic ones have to look like. Our geometric ones have to look like some number times some number to a power. That's not what that looks like. So we just have to crank them out and add them. That's what we do. Alrighty, now this one has a big hint here. It says, using series formulas. So let's just say I took a pass on number 14 because I'm thinking, I don't know which formula to use. When I get down to this one, I should go, oh, that's right. There's one on here that doesn't have a formula. I have to crank them out and find out what they are. Okay, now this one we have to use the formulas for. So does that look like it's arithmetic or geometric? It is arithmetic. mx plus b. Arithmetic. So then I go to my formula sheet and I'm looking for the big S, and it has to have a plus in it because it's arithmetic, and that is little boy Gauss's formula. S sub n equals n over 2 times the quantity a sub 1 plus a sub n. Do we know how many we're supposed to add up? Yes, 22. Remember, upper limit minus lower limit plus 1. So that's going to be 22 of them. Do we know what the first one is? Can we get it? How do we get it? Exactly. Take this number and plug it in. This is your lower limit. Negative 2 times 1 is negative 2. Negative 2 plus 5 is 3. I don't see the last term up there. Can we get it? Yes, remember the formula will give us any of the terms. So we'd have to put a 22 up here and take negative 2 times 22, which is negative 44. Negative 44 plus 5. Like so. 22 divided by 2 is 11. 3 plus negative 39 is negative 36. Again, you wouldn't have to do any of that in your head if you didn't want to. You could just punch it all in. So we need 11 times negative 36. Ta-da! Negative 396. I want to make sure I have the same test sitting up here as you guys do. it does match. Okay, I thought maybe I copied off a different one for you guys for the practice test. There's our sum. Ta-da! Well, 16 surely does not look arithmetic. What does that look like? That is definitely geometric. That looks just like our geometric rules. A sub 1 times r to the n minus 1. So, I'm looking at my formula sheet. I'm looking for the big S, but it can't have a plus in it. And I find that monster. Which, remember, we shouldn't be too scared of because it's really easy to use. All we have to do is put the numbers in, and then we'll get the calculator to do the rest of the work for us. How many numbers are we supposed to be adding up here? 10 of them. 10 minus 1, upper limit minus lower limit plus 1. Okay, so there's 10 of them. How are we going to get the first one? Put a 1 in. Yeah. 1 minus 1 is 0. Anything to the 0 power is 1. 3 times 1 is 3. You wouldn't have to do that in your noggin either. You could grab your calculator and punch in 3 times 2 to the 1 minus 1. You'll get 3. All right, now, we have to be able to look at that and know what r is. What's r? It is 2, because that's what's being raised to the power. R is whatever's being raised to the power. And we need that to the 10th power. And here's my advice, since it might be a negative on the test. Always put parentheses around that, no matter what. And then you won't mess up when you punch it in. You know, always put parentheses around there. And then down here, 1 minus 2. Now, if you wanted to punch this all in as one monster, you would need to put another set of parentheses to let the calculator know this is everything on the top and this is everything on the bottom. But like I said, I usually just do this little bit of math myself. 1 minus 2, that's negative 1. 3 divided by negative 1 is negative 3. And then it becomes much easier to punch into the calculator. Because with 2 to the 10th, we're going to use a calculator. So we have 2 to the 10th, 1 minus that answer, times negative 3. Ta-da! We have our sum. Oops, I transposed the last 2 numbers, didn't I? There we go. So, what do you suppose happens if somebody puts a 1 in, puts a 2 in, a 3 in, a 4 in, a 5 in, a 6 in, a 7, 8, 9, 10, and then adds them all up? How many points do you think they're going to get on number 16? Big goose egg. Nothing. It says you have to use the formulas. So you have to know which formula to use, and you have to put it in. That's how it works. That's what we've been doing every day. Oh, these look like fun. Evaluate each infinite geometric series, if possible, and state if it converges or diverges. Well, that's kind of backwards, because we'd want to know. If it converges, we can find it. If it diverges, we can't. So that we're going to have to check that first anyway. Alrighty. So taking a look at 17. Is it getting smaller and smaller and smaller? So what we really want to find is r. That's what we really want to find. You remember how to get it? Chloe, do you remember? Oh, you're doing the mean. Take any term and divide it by the term before it. Yeah, so you could either do 7.5 divided by 15 or 15 divided by 30. Most people will probably see that as 1/2 right away. So that's a fraction between 0 and 1. That means we can find it. That is converges. Okay, and then I remember, oh, that was the super easy formula that doesn't have an n because it's infinite. Dot, dot, dot is infinite. And I look on my paper and I see that little baby formula. And that makes me happy. Because that's a nice little simple formula. All I have to know is the first term and r. What is the first term? It's 30. And we just found r. What was it? It was a half. So this is going to be 30 divided by a half, which, if you just quickly multiplied by the reciprocal, gives you 60. Or you grab a calculator. Either way. There it is. Got it. 18. Now that's interesting, because that's kind of hard to tell if it's getting smaller or not, because it's going positive, negative, positive, negative. Let's see. I'm going to use the smaller numbers. Negative 25 divided by 75. What does that reduce to? How many times is 25 going to 75? It doesn't matter that it's negative. What matters is it's 1/3. So we can do this one. This is converges. And we get our secret little fabulous formula. Okay, it's not a secret, but it just seems like it ought to be because it's such a cute little formula. Do we know what the first number is? It is 675. And I'm pretty sure we just found r. What was r? Well, negative 1/3. So we will have 675 divided by 4/3. But if we want to do it by hand, we do not divide by fractions. We multiply by the reciprocal. But we're going to crank it in anyway. So 675 times 3/4. 506.25. And if you really wanted to, you could do math number 1. 2025 fourths. It looks more impressive, but it is the same answer because this one didn't go on forever. We're not rounding or anything with that answer. It's perfect. Okie doke. 19. Getting smaller?
No.
Uh-oh. What do we do?
No solution.
Diverges. We can't find it. You're right. No solution.
Yeah, you did, but I was right.
Now, we're going to write diverges, and then there's some stuff we can write in sum. Basically, if you just do this, I'll know that you knew you can't find it. You could write no sum. That would absolutely be true. If you really want to write something in that little blank. No sum would be good. Can't find it. That would be another good statement. But we can't do that one because it's getting bigger and bigger and bigger, and it's never going to stop. That's what the ... is for. Alrighty. Well, that made some headway. Now we're at 20, huh? 20 says it's all up to us. Determine whether each series is arithmetic or geometric. Then evaluate the finite series for the specified number of terms. Take a look at 20. Arithmetic? Is it? What are they adding every time? So you just told me what D is. We're going to put arithmetic over here. Now, for arithmetic problems like this, you're going to have to write the rule. We always have to. But you probably are going to start with the sum formula and then realize you're missing something. So this is little boy Gauss's again. And right away we see, well, we have to know how many. Did they tell us how many? They did. Back here it says there's 10 of them. Do we know the first one? It's a 2. Do we know the last one? See, there it is. We've got to write the rule. It happens almost, well, 50% of the time when you're working with arithmetic formulas. You have to find that missing piece. So we need the rule because we need to know what that last number is. The good news is we know what a sub 1 is and we know what D is. This is not going to be hard. A sub 1 is 2. And you told me they were adding 6. So let's simplify that. Looking good. Now what did we need? What do we write that for? We need the 10th term. We need that last term. 6 times 10? 60. Minus 4? 56. Hey, we're almost done. So we needed that to find that last term. And now, if you wanted to do some basic math, you could. Or you could just punch it in. 5 times 58. 290. So, that's not a difficult process. It just takes a while. And you have a lot of things to get together there, to pull together to get your answer. Alrighty, now, let's use some logic here. If that was arithmetic, what's the other one probably going to be? Yeah, because we want to see that you're able to do one of each, right? But let's just make sure. Let's find R and make sure that they're multiplying by the same thing every time. What do you see? Negative 4? So geometric. All right, so I've got my formula sheet. I know I need the big sum thing with the n, but it can't be the one with the plus. So it's a sub 1 times 1 minus r to the n over 1 minus r. And I'm hoping I have everything I need this time so I don't have to write the rule, but you never know. Alrighty, how many of these are we supposed to find? The first 8. Do we know what the first one is? It's a 3. Do we know what they're multiplying by each time? And that's why I said it's just a good habit to always get into putting that R value in parentheses, because the power on this has to be done first, and the power is 8. And when you take negative 4 to the 8th, it's going to become positive. And if you don't punch it in right, you're going to have trouble. So down here, 1 minus a negative 4. Hey, we had everything. We didn't have to write a rule. That happens a lot with the geometric. So now let's do a little math in the noggin. 1 minus the negative 4 is 5. So this will be 3/5 times 1 minus negative 4 to the 8th. And that will give us our answer. Oops, that's an awfully large 8. So I'll follow the order of operations and do the powers first, then the parentheses will get finished up. So parentheses, negative 4, parentheses, to the 8th, 1 minus that answer, times parentheses, 3/5 parentheses. Blammo, negative 39, 321. Makes me a little nervous. That's a rather large negative number, isn't it? Should it have been? You're multiplying by negative 4 every time. Yeah, it should be. All right, we're closing in on it. Oh, a word problem. Oh, it's got to be really hard. On October 1st, a gardener plants 40 bulbs. On October 2nd, she plants 44 bulbs. She really likes tulips. On October 3rd, she plants 48 bulbs. She continues in this pattern until October 15th, when she plants the last bulbs. Write an explicit formula to model the number of bulbs she plants each day. Is it arithmetic? Geometric? Neither?
Arithmetic.
Oh. How did we know it was arithmetic? Yeah, adding 4 every time. So just by looking at it, we see that D is 4. What did they say she planted on the first day? 40. And we said 4 each day. Let's clean it up and we'll have our formula. 40 plus 4n minus 4. So that'll be 4n plus 36. Beautiful. How many bulbs will the gardener plant on October 15th? Started October 1st. How many days are we talking about? 15. N equals 15. Well, we can use our little formula for that. A sub 15 equals 4 times 15 plus 36, because they just want to know about that day. They don't want to know how many she's planted every day since. So this will give us 60 plus 36 for a grand total of how many bulbs? 96 bulbs. Tulips, daffodils, all those early spring bulbs. There it is. Anything that we went over yesterday or today, maybe you were thinking about this last night, hey, I should ask her to make another one of those. Any of these that you'd like to see?
I will definitely let you know.
Okay. All right, well, then let me get you candy, partner.